Welcome back to Daily Dose of Space. Throughout history, astronomy has been about patterns. Stars move in predictable ways. Galaxies follow well-understood rules. Light behaves according to equations we trust, because they work almost every time. Almost. Every once in a while, the universe does something that doesn't fit. Something appears in our data that refuses to behave the way it should. It doesn't repeat when expected. It doesn't match known sources. And no matter how carefully we look at it, it leaves behind more questions than answers. Today, we're talking about one of those moments. A single detection from deep space that even decades later remains one of the strangest things we've ever observed. Not because it proved anything extraordinary, but because we still don't know what it was. A normal night at the telescope. The discovery didn't begin with excitement. It began with routine. In August 1977, the Big Ear radio telescope in Ohio was doing exactly what it was designed to do. It was quietly scanning the sky, listening for narrowband radio signals that might indicate something artificial rather than natural background noise. No one was sitting at the telescope at the time. The data was recorded automatically, printed on long sheets of paper, and analyzed later by volunteers. This was slow science, careful science, and incredibly patient science. When one of those volunteers, Jerry Amon, reviewed the printout days later, he noticed something unusual. A spike. Not a small one, not a vague anomaly. A strong, narrowband radio signal that appeared suddenly, grew in intensity, and then faded away over 72 seconds. Exactly the amount of time the telescope would take to pass over a fixed point in the sky. Amon circled the signal on the printout and wrote a single word next to it. Wow! That moment would define decades of speculation. Why this signal was different. Radio signals from space are not rare. Pulsars, quasars, and cosmic noise constantly fill the sky. But this signal was different in ways that immediately stood out to astronomers. First, it was extremely narrow in frequency. Natural sources tend to spread their energy across a wide range of frequencies. This signal was tightly focused, something we normally associate with technology rather than astrophysics. Second, it came from a region of the sky near the constellation Sagittarius, close to where the center of the Milky Way lies. This is a crowded region, full of stars, gas, and complex dynamics. And third, it never appeared again. The telescope scanned the same region many times afterward. Other observatories listened as well. Nothing. No repeat. That single brief signal became known as the WOW signal, and its silence afterward made it even stranger. The first explanations. At first, scientists did what they always do. They tried to explain it without invoking anything extraordinary. Could it have been a satellite? Unlikely, since satellites move relative to the stars and would have produced a different signal pattern. Could it have been interference from Earth? Also unlikely. The signal was detected in only one of the telescope's beams and matched the behavior expected from a distant source fixed in the sky. Could it have been a known astronomical object? Pulsars didn't fit. Quasars didn't fit. Solar system objects didn't fit. The signal was strong, narrow, and brief. And that combination was deeply uncomfortable, because while none of this proved an artificial origin, it made natural explanations increasingly difficult, which is why, reluctantly, the most controversial idea entered the conversation. The alien question. No serious scientist claimed the WOW signal was proof of extraterrestrial intelligence, but many admitted something unsettling. If you were trying to design a signal that would stand out against natural cosmic noise, this is exactly what it might look like. A narrowband transmission, a frequency near hydrogen, the most abundant element in the universe. A duration matching the movement of a radio telescope across the sky. These details didn't mean it was artificial, but they made it impossible to dismiss the idea entirely. SETI researchers became obsessed with the signal, not because it proved anything, but because it was clean. It didn't look messy or chaotic, it looked deliberate. And that was the problem. Science is built on repetition. One-time events are nearly impossible to confirm. Without a repeat detection, the signal remained an open wound in astronomy. New ideas, new problems. Decades later, new explanations began to emerge. One of the most popular involved comets. In 2017, a study suggested that hydrogen clouds surrounding passing comets could have produced the signal. 2 comets happened to be near the signal's coordinates at the time. It sounded promising, until other astronomers pointed out that similar cometary signals should be common. They aren't. Radio telescopes have observed thousands of comets since then. None have produced anything like the wow-wow signal. Other ideas followed: exotic stellar flares, unusual maser activity, rare magnetospheric events. Each explanation solved part of the puzzle while creating new inconsistencies. The signal remained stubbornly unexplained. Why it still matters. You might wonder why a single signal from nearly 50 years ago still matters. Because astronomy is not just about what we see, it's about what we expect to see. The wow signal sits uncomfortably at the edge of our models. It is a reminder that the universe can still surprise us, even with simple instruments and accidental discoveries. It also changed how SETI operates. Today's searches rely on continuous monitoring, wide coverage, and automated systems designed specifically to catch transient signals like this one. In a strange way, the wow-wow signal became a warning. If something truly extraordinary happens, it may not repeat. And if we aren't listening at the right moment, we may miss it forever. The strangest thing about the wow signal is not what it was. It's that we still don't know. It could have been a rare natural phenomenon we don't yet understand. It could have been an artificial signal that never repeated. Or it could have been something else entirely. The universe does not owe us explanations. Sometimes it leaves us with a question and moves on. And somewhere out there, whatever produced that signal may still exist. Silent, distant, unnoticed.